Hi, I am Ali and I will be explaining Minerva Intelligence's water pollution exploratory data analysis platform. The platform can be accessed on waterpollution.minervaintelligence.ai, and it is intended not just for exploratory data analysis but also for display of AI outputs once they are available. You will need a username and password to log in. This project was initiated to evaluate the advantages of adopting a knowledge engineering-based AI approach to the identification of environmental pollution events in large complex databases of water quality. Because the European Union has implemented a number of terminological standards dealing with environmental pollution, it was decided to choose an EU dataset for our first case study. Terminological standards are important to knowledge engineering. A suitable European Environmental Agency water quality database was identified. The database has water pollution samples from river stations and underground water stations all over Europe. Every sample in the dataset is acquired from a water pollution sampling station. The yellow dots on the map are only the river stations from this dataset. Every sample has the information about what pollutant the sample is for, when the sample was taken, and at which station the sample was taken. It is worth mentioning that the database did not have any information about how the river stations are connected with rivers. The first thing we did was to match the stations with rivers downloaded from OpenStreetMap. At this point, we knew which station is upstream or downstream to the other stations. On the map, you can see a sample basin which includes only part of the dataset. As you can see, this basin is in France, and the water in this basin is mostly flowing from east to west. Now I will explain how to interact with the UI. You can click on any station. The clicked station will change color to red, and its upstream stations will get unique colors. After this, when you scroll down, you can see the samples in those stations for different chemicals. The colors in the plots match the unique colors of the stations. On the top of the page, on the right, you can check a few chemicals. The first effect of selecting some chemicals is that on the map, the set of stations which have the data for those chemicals in the selected years will turn black. For example, now we know that only the black stations have the data for nitrate in 2017. Now, the black stations have data for either nitrate or lead in 2017. When I change the mode from union to intersection, the stations that have nitrate and lead in 2017 will be black. The second effect of selecting some chemicals is that the plots for the checked chemicals will appear at the top of the time series plots below the map. You can also select some years so that the plots will show the samples from the chemicals for those years. You can also select the radio button for a single chemical and a single year. This changes the map to display possible pollution events. This will only affect the color of the rivers. The rivers are colored more red if our simple analysis shows that the selected chemical was added more along the river at that point. Blue river color shows that our simple analysis did not reveal any signs that this chemical was added significantly in this part of the river. Under the map, there is also a favorite section which can be used to save a favorite station and go back to it at a later time. Currently, all users share the same favorites list. When you save a favorite station, the clicked station, selected chemicals, and selected years are stored. Selecting Go on a favorite listing will also pick the correct basin for the station. A knowledge engineering approach to complex data evaluation usually requires identification of features in the data that an expert would find important and then reason about. This step in an AI system is called signal-to-symbol transformation, and I will now describe how this system identifies peaks in the time series of water compositions. Pollutant peaks, if they are high enough, are one kind of feature water quality experts will often reason about. Under every plot, there are two links. The link about peak detection will open a tab that will show the result of an experimental signal to symbol transformation that is doing peak detection. When you hover over every peak, some information about the peak is shown, including its ID, which will be useful later. The plan is that we can use Minerva's reasoner to reason about the detected peaks and their properties to quickly identify all pollution events recorded in the data that an expert would identify if he or she had enough time. The general additive model is another experimental model which is trying to model the data to distinguish anomalous sample points from other points. This model is at its very first stages and is only shown for phosphate. The plot filtering tool can help you filter plots that have very few value levels, which are not very interesting. The basin selection tool will allow you to interact with the whole dataset. You can see other stations that are in different basins. Most of the explained actions work on all the basins, and if any of them doesn't work in other basins, it can be added to all the basins very easily. The peak finder tool is used to find the peak using its ID. It is part of the peak signal to symbol transformation method.